My name is Jordan Boyd Graber, and I'm going to do an experiment today. I need to create a camera-ready version of the paper. And usually when I do that, I read the paper out loud to find any remaining typos. I was once doing this on campus, and a student who had a vision impairment said, "Hey, you should record that. That would be really useful to people like me who need to read a paper." And I thought, well, I'm doing it anyway, I'll try to record it, and we'll see what happens. And so, apologies for the low quality of this video compared to some of my other videos. We're in Corona lockdown, and so the lighting isn't as good as it usually is, and my haircut, well, it's never great, but even worse than usual. But without further ado, let me begin reading a paper. This paper is called What Question Answering Can Learn from Trivia Nerds. This is a paper written by myself and Benjamin Böschinger during my sabbatical at Google Zurich. So I'm going to try to read this in a way that would actually be interesting to someone listening to it. So I'm not going to go over the figures. I'm not going to mention citations that would disrupt the flow. I'm just going to read it in a way that would hopefully be interesting, and it will also help me to make sure that the paper flows well without going on diversions of footnotes and things like that. And if you've read my papers, you know that I like footnotes and parenthetical remarks and things like that, so I will skip those without further ado. This paper takes an unconventional analysis to answer where we've been and where we're going in question answering. Instead of approaching the question only as computer scientists, we apply the best practices of trivia tournaments to QA datasets. The QA community is obsessed with evaluation. Schools, companies, and newspapers hail new state-of-the-arts and topping leaderboards, giving rise to troubling claims that an AI model tops humans because it won some leaderboard, putting millions of jobs at risk. But what is a leaderboard? A leaderboard is a statistic about question answering accuracy that induces a ranking over participants. Newsflash, this is the same as a trivia tournament. The trivia community has been doing this for decades. We'll talk about, in section 2, this overlap between the qualities of a first-class question-answering dataset. That the experts running these tournaments are imperfect, but they've learned from their past mistakes and created a community that reliably identifies those best at question answering. Beyond the format of the competition, trivia norms ensure that individual questions are clear, unambiguous, and reward knowledge. We're not saying that academic question answering should surrender to trivia questions or the trivia community. Far from it. The trivia community does not understand the real-world information-seeking needs of users or what questions challenge computers. However, they have well-tested protocols to declare that someone is better at answering questions than another. This collection of tradecraft and principles can nonetheless help the question answering community. Beyond these general concepts that QA can learn from, we review how the gold standard of trivia formats, Quiz Bowl, can improve traditional question answering. We then briefly discuss how research that uses fun, fair, and good trivia questions can benefit from the expertise, pedantry, and passion of the trivia community. Section 2. Surprise! This is a trivia tournament. My research isn't a silly trivia tournament, you say. That may be, but let us tell you a little bit about what running a tournament is like, and perhaps you can see the similarities. First, the questions. Either you write them yourself or you pay someone to write questions by a particular date. Then you advertise. You talk about your questions, who is writing them, what subjects are covered, and why people should try to answer them. Next, you have your tournament. You keep your questions secure until test time, collect answers from all participants, and declare a winner. Afterward, people use the questions to train for future tournaments. These have natural analogs to crowdsourcing questions, writing the paper, advertising, and running a leaderboard. Trivia nerds cannot help you form hypotheses or write your paper, but they can tell you how to run a fun, well-crafted, well-calibrated, and discriminative tournament. Such tournaments are designed to effectively find a winner, which matches the scientific goal of knowing which model best answers questions. Our goal is not to encourage the QA community to adopt the quirks and gimmicks of trivia games. Instead, it's to encourage experiments and datasets that consistently and effectively find the systems that best answer questions. Are we having fun yet? Many authors use crowd workers to establish human accuracy. However, they are not the only humans who should answer datasets questions. So should the datasets creators. In the trivia world, this is called a playtest. Get in the shoes of someone answering the questions. If you find them boring, repetitive, or uninteresting, so will crowd workers. If you can find shortcuts to answer questions, so will a computer. Concretely, Weisenborn et al. Catalog Artifacts and Squad, the most popular QA leaderboard. If you see a list like, along with Canada, the United Kingdom, what country, you can ignore the rest of the question and just type Control F to find the country, Australia in this case, that appears with Canada and the UK. Other times, a squad playtest would reveal frustrating questions that are unanswerable given the information but not with a direct span, answerable only given facts beyond the given paragraph, or unintentionally embedded in a discourse resulting in arbitrary correct answers or non-questions. SearchQA, derived from Jeopardy, asks, an article that he wrote about his riverboat days was eventually expanded into Life on the Mississippi. The apprentice and newspaper writer who wrote that article is named Samuel Langhorne Clemens. However, the reference answer is his later pen name, Mark Twain. Most QA evaluation metrics would count Samuel Clemens as incorrect. In a real game of Jeopardy, this would not be an issue, and we'll talk about that later. Of course, fun is relative, and any dataset is bound to contain errors. However, playtesting is an easy way to find systematic problems. Unfair, unfun playtests make for ineffective leaderboards. Eating your own dog food can help diagnose artifacts, scoring issues, or other shortcomings early in the process. The deeper issues when creating a QA task are, have you designed a task that is internally consistent, supported by a scoring metric that matches your goals, and using gold annotations that reward those who do the task well? Imagine someone who loves answering questions your task poses. Would they have fun on the task? This is the foundation of gamification, which can create quality data from users motivated by fun rather than play. Even if you pay crowd workers, unfun questions may undermine your dataset goals. Am I measuring what I care about? Answering question requires multiple skills: identifying answer mentions, naming the answer, abstaining when necessary, and justifying an answer. In QA, the emphasis on state-of-the-art and leaderboards has focused attention on single, automatically computable metrics. Systems tend to be compared by their SWOD score or natural question score, as if this were the only thing to say about their relative capabilities. Like question answering leaderboards, trivia tournaments need to decide on a single winner. But they explicitly recognize that there are more interesting comparisons. A tournament may recognize different backgrounds or resources, high school, small school, undergraduate. Similarly, more practical leaderboards would reflect training time or resource constraints, including constrained or unconstrained training. Tournaments also give specific awards, for example, the highest score without incorrect answers. Again, there are obvious leaderboard analogs that would go beyond a single number. In Squad 2.0, abstaining contributes the same to the overall F1 as a single correct answer, obscuring whether a system is more precise or an effective abstainer. If the task recognizes both abilities as important, reporting a single score risks implicitly prioritizing one balance of the two. Do my questions separate the best from the rest? Assume that you have picked a metric or a set of metrics that captures what you care about. A leaderboard based on this metric can rack up citations as people chase the top spot. But your leaderboard is only useful if it's discriminative. The best system reliably wins. There are many ways questions might not be discriminative. If every system gets a question right, for example, abstain on non-questions like ASDF, or correctly answer what is the capital of Poland, the dataset does not separate participants. Similarly, if every system flubs what is the oldest north-facing kosher restaurant, it is not discriminative. Sugawara et al. Call these questions easy and hard. We instead argue for a three-way distinction. In between easy questions, system answers correctly with probability 1.0, and hard, probability 0.0, questions with probability nearer to 0.5 are more interesting. Taking a cue from Vygotsky's proximal development theory of human learning, these discriminative questions, rather than the hard ones or the easy ones, should most improve QA systems. These Goldilocks questions, as we'll call them, not random noise, decide who tops the leaderboard. Unfortunately, existing datasets have many easy questions. Sugawara find that ablations like shuffling word order, shuffling sentences, or only offering the most similar sentences do not impair systems. Newer datasets such as Drop and HelloSwag are harder for today's systems. Because Goldilocks is a moving target, we propose annual evaluations later on. Why so few Goldilocks questions? This is a common problem in trivia tournaments, particularly pub quizzes, where challenging questions can scare off patrons. Many quizmasters prefer popularity with players, and thus write easier questions. Sometimes there are fewer Goldilocks questions not by choice, but by chance. A dataset becomes less discriminative through annotation error. All datasets have some annotation error. If this annotation error is concentrated on the Goldilocks questions, the dataset will be less useful. As we write this in 2020, humans and computers sometimes struggle on the same question. Figure 1 shows two datasets of the same size with the same annotation error. However, they have different difficulty distributions and correlation of annotation error and difficulty. The dataset that has more discriminative questions and consistent annotator error has fewer questions that do not discriminate the winner of the leaderboard. We call this the effective dataset proportion row. Higher is better. Figure 2 shows the test size required to reliably discriminate systems for different row based on a simulation. At this point, you might despair about how big a dataset you actually need. The same terror besets trivia tournament organizers. Instead of writing more questions, they use something called pyramidality to make every question count. Section 3, the craft of question writing. Trivia enthusiasts agree that questions need to be well written, despite many other disagreements. Asking good questions requires sophisticated pragmatic reasonings, and pedagogy explicitly acknowledges the complexity of writing effective questions for assessing student performance. Question answering datasets, however, are often collected from the wild or written by untrained crowd workers. Crowd workers lack experience in crafting questions and may introduce idiosyncrasies and shortcut machine learning. Similarly, data collected from the wild, such as natural questions or Amazon QA, by design have vast variations in quality. In the previous section, we focused on how datasets as a whole should be structured. Now, we focus on how specific questions should be structured to make the dataset as valuable as possible. Avoiding ambiguity, abstractions, and assumptions. Ambiguity in questions not only frustrates answerers who resolve the ambiguity incorrectly, ambiguity also frustrates the goal of using questions to assess knowledge. Thus, the U.S. Department of Transportation explicitly bans ambiguous questions from exams for flight instructors. And the trivia community has likewise developed rules and norms that prevent ambiguity. While this is true in many contexts, examples are rife in a format called Quiz Bowl, whose very long questions showcase trivia writers' tactics. For example, Quiz Bowl author Zhu Ying, writing for the 2005 Parfait tournament, asked participants to identify a fictional character while warning against possible confusion. Here's the question. He's not Sherlock Holmes, but his address is 221B. He's not the janitor on Scrubs, but his father is played by R. Lee Ermey. For 10 points, name this misanthropic, crippled, Vicodin-dependent central character of a Fox medical drama. And the answer is, of course, Gregory House, MD. In contrast, QA datasets often contain ambiguous and underspecified questions. While this sometimes reflects real-world complexities such as actual underspecified or ill-formed search queries, Ignoring this ambiguity is problematic. As a concrete example, Natural Questions answers, what year did the US hockey team win the Olympics? With 1960 and 1980. Ignoring the US women's team, which won in 1998 and 2018. And further assuming that the question is about ice rather than field hockey, which is also an Olympic event. Natural Questions associates a page about the United States men's national hockey team to the question, arbitrarily removing the ambiguity post hoc. However, this does not resolve the ambiguity, which persists in the original question. Information retrieval arbitrarily provides one of many interpretations. True to their name, natural questions are often underspecified when users ask a question online. The problem is neither that such questions exist nor that the machine reading QA considers questions given an associated context. The problem is that tasks do not explicitly acknowledge the original ambiguity and gloss over the implicit assumptions in the data. This introduces potential noise and bias in leaderboard rankings. At best, these will become part of the measurement error of datasets. No dataset is perfect. At worst, they will recapitulate the biases that went into the creation of the datasets. Then the community will implicitly equate the biases with correctness. You get high scores if you adopt this set of assumptions. These then enter into real-world systems, further perpetuating the bias. Playtesting can reveal these issues, as implicit assumptions can rob a player of correctly answered questions. If you wanted to answer 2014 to when did Michigan last win the championship, when the Michigan State Spartans won the women's cross-country championship, and you can't because you chose the wrong school, the wrong sport, and the wrong gender, you would complain as a player. Researchers instead discover latent assumptions that creep into the data. It's worth emphasizing that this is not a purely hypothetical problem. For example, open domain retrieval question answering deliberately avoids providing a reference context for the question and its framing, but in repurposing data such as natural questions, opaquely relies on it for the gold answers. Avoiding superficial evaluations. A related issue is that, in the words of Voorhees and Tice, there is no such thing as a question with an obvious answer. As a consequence, trivia question writers delineate acceptable and unacceptable answers. For example, in writing for the trivia tournament Harvard Fall 11, Robert Chu uses a mental model of an answerer to explicitly delineate the range of acceptable correct answers. In Newtonian gravity, this quantity satisfies Poisson's equation. For a dipole, this quantity is given by negative the dipole moment dotted with the electric field. For 10 points, name this form of energy contrasted with kinetic. And the answer line reads potential energy, but prompt on energy, except specific types like electrical potential energy or gravitational potential energy do not accept or prompt on just potential. Likewise, the style guides for writing questions stipulate that you must give the answer type clearly and early on. These mentions specify whether you want a book, a collection, a movement, etc. It also signals the level of specificity requested. For example, a question about a date must state day and month required, month and year required, or day, month, and year required. This is true for other answers as well, city and team, party and country, or more generally, 2 answers required. Despite these conventions, no predefined set of answers is perfect, and every worthwhile trivia competition has a process for adjudicating disagreements and answers. In major high school and collegiate national championships and game shows, if low-level staff can't resolve the issue by throwing out a single question or accepting minor variations, for example, America instead of the United States of America, the low-level staff contacts the tournament director. The tournament director, who has a deeper knowledge of the rules and the questions, often decide the issue. If that's still not possible, the protest goes on through an adjudication process designed to minimize bias. Write the summary of the dispute, get all parties to agree on the summary, and then hand the question off to mutually agreed experts from the tournament's phone tree. The substance of the disagreement is communicated without identities, and the experts apply the rules and decide. For example, when a particularly inept Jeopardy contestant, yours truly.
What is the Fairy Queen?
Yes.
Operation 2000.
Your surgeon could choose to take a look inside you with this type of fiber optic instrument. Jordan.
What is an endoscope?
Nope. Evelyn.
What is a laparoscope?
That's it.
Since the Van Doren scandal, every television trivia contestant has an advocate assigned from an auditing company. In this case, the advocate initiated a process that went to a panel of judges who then ruled that endoscope, a more general term, was also correct.
Before we get into the final, a brief explanation for the reason that the scores are different now than they were a few seconds ago when we went into the commercial break. We should have been a little bit more specific on our clue about the laparoscope. Turns out the laparoscope is a kind of endoscope, so we are crediting Jordan with an extra 4,000.
The need for a symbol process seems to have been well recognized in the earliest days of question answering system bake-offs such as Trek QA, and Voorhees notes that different QA runs seldom return exactly the same answer, and it is quite difficult to determine automatically whether the difference is significant. In stark contrast to this, QA datasets typically only provide a single string, or if one is lucky, several strings. A correct answer means exactly matching these strings and at least having a high token overlap F1, and failure to agree will put you in an uncontestable disadvantage on the leaderboard. To illustrate how current evaluations fall short of meaningful discrimination, we qualitatively analyzed two near state-of-the-art systems on Squad version 1.1. The original XLNet and the subsequent iteration called XLNet 123. Despite XLNet 123's margin of almost 4 absolute F1 on development data, a manual inspection of 100 of XLNet 123 wins indicate that around 2/3 are spurious. 56% are likely to be considered not only equally good, but essentially identical. 7% are cases where the answer set omits a correct alternative, and 5% of cases are bad questions. Our goal is not to dwell on the exact proportions, to minimize the achievements of these strong systems, or to minimize the usefulness of quantitative evaluation. We merely want to raise the limitation of blind automation for distinguishing between systems on a leaderboard. Taking our cue from the trivia community, we present an alternative for MRQA. Blind tests are created for a specific time. All systems are submitted simultaneously. Then all questions and answers are revealed. System authors can protest correctness rulings on questions directly addressing the issues above. After agreement is reached, quantitative metrics are computed for comparison purposes. Despite their inherent limitations, they can at least be trusted. Adopting this for MRQA would require creating a new, smaller test set every year. However, this would gradually refine the annotations and process. This suggestion is not novel. Voorhees and Tice accept automatic evaluations for experiments internal to an organization where the benefits of a reusable test collection are most significant, and the limitations are likely to be understood. But that satisfactory techniques for automatically evaluating new runs have not been found yet. We are not aware of any change on this front. If anything, we seem to have just become more insensitive as a community to just how limited our current evaluations are. Focus on the bubble. While every question should be perfect, time and resources are limited. Thus, authors and editors of tournaments should focus on the bubble, where the bubble are the questions most likely to discriminate between the top teams at the tournament. These questions are thoroughly place-tested, vetted, and edited. Only after these questions have been perfected will the other questions undergo the same level of polish. For computers, the same logic applies. Authors should ensure that these discriminative questions are correct, free of ambiguity, and unimpeachable. However, as far as we can tell, the authors of QA datasets do not give any special attention to these questions. Unlike a human trivia tournament, however, with finite patience of the participants, this does not mean that you should necessarily remove all of the easy or hard questions from your dataset. This could inadvertently lead to systems unable to answer simple questions like, who is buried in Grant's tomb? Instead, focus more resources on the bubble. Section 4. Why Quizbowl is the gold standard. We now take what has been a wide-ranging discussion of question answering generally and focus it on a specific format, Quizbowl, which has many of the desirable properties outlined above. we have no delusion that mainstream question answering will adopt this format. However, given the community's emphasis on fair evaluation, computer QA can borrow aspects from the gold standard of human QA. We've been showing you examples of specific Quiz Bowl questions, but we have not explained how the format works. You can see Rodriguez et al. For more. You might be scared off by how long the questions are. However, in real Quiz Bowl tournaments, they are not finished because the questions are designed to be interruptible. A moderator reads a question. Once someone knows the answer, they use a signaling device to buzz in. If the player who buzzed is correct, they get points. Otherwise, they lose points, and the question is read for the other team. Not all trivia games with buzzers have this property, however. For example, take Jeopardy, the subject of Watson's tour de force. While Jeopardy also uses signaling devices, they only work once the question has been read in its entirety. Ken Jennings, one of the top Jeopardy players, and also a quiz bowler, explains it on a Planet Money interview.
The deal with the buzzer is this. The buzzer is not live until Alex finishes reading the question. And if you buzz in before your buzzer goes live, you actually lock yourself out for a fraction of a second. So the big mistake on the show is people who are all adrenalized and are buzzing too quickly, too eagerly.
Okay. To some degree, Jeopardy is kind of a video game, and a crappy video game where it's like, light goes on, press button. That's it.
Yeah.
Is that true?
I do like to think of it as a beautiful art and not a really crappy video game.
Jeopardy's buzzers are a gimmick to ensure good television. However, Quiz Bowl buzzers discriminate knowledge. Similarly, while Trivia QA is written by knowledgeable writers, the questions are not pyramidal. Recall that effective datasets discriminate the best from the rest. The higher the proportion of effective questions row, the better. Quiz Bowl's row is nearly 1 because discrimination happens within a question. After every word, an answerer must decide if they know enough to answer. Quiz Bowl questions are arranged so that the questions are maximally pyramidal. Questions begin with hard clues, ones that require deep understanding, to move to accessible clues that are well known. Well edited. Quiz Bowl questions are created in phases. First, the author selects the answer and assembles pyramidal clues. A subject editor then removes ambiguity, adjusts acceptable answers, and tweaks clues to optimize discrimination. Finally, a packetizer ensures the overall set is diverse, has uniform difficulty, and is without repeats. Unnatural. Trivia questions are fake. The asker already knows the answer. But they're no more fake than a course's final exam, which, like leaderboards, are designed to test knowledge. Experts know when questions are ambiguous. While what play has a character whose father is dead could be Hamlet, Antigone, or Proof, a good writer's knowledge avoids the ambiguity. When authors omit these clues, the question is derided as a hose, which robs the tournament of fun. One of the specific benefits of contrived formats is focus on specific phenomena. Dua et al. Exclude questions an existing MRQA system would answer to focus on challenging quantitative reasoning. One of the trivia experts consulted in Wallace et al. Created a question that tripped up neural QA by embedding the phrase, "This author opens Crime and Punishment," into a question the top system confidently answers Fyodor Dostoevsky. However, that phrase was in a longer question. The narrator in Cogwheels by this author opens Crime and Punishment to find that it has become the Brothers Karamazov. Again, this shows the inventiveness and linguistic dexterity of the trivia community. A counter-argument is that real-life questions, for example, those on Yahoo Questions, Quora, or web search, ignore the craft of question writing. Real humans react to unclear questions with confusion or divergent answers, explicitly answering with how they interpreted the question. I assume that you meant, given real-world applications will have to deal with the inherent noise and ambiguity of unclear questions, our systems must cope with it. However, addressing the real world cannot happen by glossing over its complexity. Complicated. Quiz Bowl is more complex than other datasets. Unlike other datasets where you need to decide just what to answer, in Quiz Bowl, you also need to decide when to answer the question. While this improves the dataset's discrimination, it can hurt popularity because you cannot copy-paste code from other QA datasets. The complicated pyramidal structure complicates some questions. For example, what is log base 4 of 64? Section 5, a call to action. You may disagree with the superiority of the quiz bowl format as a QA framework. In this section, we hope to distill our advice into a call to action regardless of your question format or source. Here are our recommendations if you want to have an effective leaderboard. Talk to trivia nerds. You should talk to trivia nerds because they have useful information, not just about the election of 1876. Trivia is not just the accumulation of information, but is also connecting disparate facts. These skills are exactly those that we want computers to develop. Trivia nerds are writing questions anyway. We can save money and time if we pool resources. Computer scientists benefit if the trivia community writes questions that aren't trivial for computers to solve. The trivia community benefits from tools that make their job easier. Show related questions, link to Wikipedia, or predict where humans will answer a question. Likewise, the broader public has unique knowledge and skills. In contrast to low-paid crowd workers, public platforms for question answering and citizen science are brimming with free if you can engage the relevant communities. For example, the core query, is there a nuclear control room on the nuclear aircraft carrier, is purportedly answered by someone who worked in such a room. As machine learning algorithms improve, the good enough crowdsourcing that got us this far may not be enough for continued progress. Eat your own dog food. As you develop new question answering tasks, you should feel comfortable playing the task as a human. Importantly, this is not just to replicate what crowdsourcers are doing, but to remove hidden assumptions, institute fair metrics, and define the task well. For this to feel real, you need to keep score. Have all of your co-authors participate and compare their scores. Again, we emphasize human and computer skills are not identical, but this is a benefit. Humans' natural aversion to unfairness will help you create a better task, while computers will blindly optimize an objective function. As you go through the process of playing on your question answering data set, you can see where you might have fallen. Part of every postmortem of trivia tournaments is a detailed discussion of the questions, where good questions are praised and bad questions are excoriated. This is not meant to shame the writers, but rather to build and reinforce cultural norms. Questions should be well written, precise, and fulfill the creator's goals. Just like trivia tournaments, QA datasets resemble a product for sale. Creators want people to invest their time and sometimes money, or GPU hours, in using their data and submitting to their leaderboards. It's good business to build a reputation for quality questions and discussing individual questions. Similarly, discussing and comparing the actual predictions made by competing systems should be part of any competition culture. Without it, it is hard to tell what a couple of points on some leaderboard mean. To make this possible, we recommend that leaderboards include an easy way for anyone to download a system's development predictions for qualitative analysis. Make questions discriminative. We argue that questions should be discriminative, and while Quiz Bowl is one solution, not everyone is crazy enough to adopt it. For more traditional QA tasks, you can maximize the usefulness of your dataset by ensuring as many questions as possible are challenging, but not impossible, for today's QA systems. But you can use some Quiz Bowl intuitions to improve discrimination. In visual QA, you can offer increasing resolutions of an image. For other settings, create pyramidality by adding metadata, co-reference, disambiguation, or alignment to a knowledge base. In short, consider multiple versions or views of your data that progress from difficult to easy. This not only makes more of your data set discriminative, but also reveals what makes a question answerable. Embrace multiple answers or specify specificity. As question answering moves to more complicated formats and answer candidates, what constitutes a correct answer becomes more complicated. Fully automatic evaluations are valuable both for training and quick turnaround evaluation. In the case annotators disagree, the question should explicitly state what level of specificity is required. Or if not all questions have a single answer, link answers to a knowledge base with multiple surface forms, or explicitly enumerate which answers are acceptable. Appreciate ambiguity. If your intended QA application has to handle ambiguous questions, do justice to the ambiguity by making it part of your task. For example, recognize the original ambiguity and resolve it. Did you mean, instead of giving credit for happening, to fit the data? To ensure that our datasets properly isolate the property that motivated the dataset in the first place, that's a quote from Zainin, 2006, we need to explicitly appreciate the unavoidable ambiguity instead of silently glossing over it. This is already an active area of research, with conversational QA being a new setting actively explored by several datasets, and other work explicitly focusing on identifying useful clarification questions, thematically linked questions, or resolving ambiguities that arise from co-reference or pragmatic constraints by rewriting underspecified question strings in context. Revel in spectacle. However, with more complicated systems and evaluations, a return to the yearly evaluations of Trek QA may be the best option. This improves not only the quality of evaluation, we can have real-time human judgment, but also lets us test the test set to reflect the build-it-break-it cycle as attempted by the 2019 iteration of Fever. Moreover, another lesson the QA community could learn from trivia games is to turn it into a spectacle, exciting games with a telegenic host. This has a benefit to the public, who see how QA systems fail and succeed, and also to QA researchers who have a spoonful of sugar of fun to inspect their system's output and their competitors. In between full automation and expensive human in the loop are automatic metrics that mimic the flexibility of human raters, inspired by machine translation evaluations, or summarization. However, it should not forget that these metrics are introduced as understudies, good enough when quick evaluations are needed for system building, but no substitute for proper evaluation. In machine translation, Laubli et al. Revealed that crowd workers cannot spot the errors that neural NT systems make. Fortunately, trivia nerds are cheaper than professional translators. Be honest in crowning QA champions. Leaderboards are a ranking over entrants based on a ranking over numbers. This can be problematic for several reasons. The first is that single numbers have some variance. It's better to communicate estimates with error bars. Well, particularly for leaderboards, it is tempting to turn everything into a single number. Recognize that there are often different subtasks and types of players or systems that deserve recognition. A simple model that requires less training data or runs in 10 milliseconds may be objectively more useful than a bloated, brittle monster of a system that has slightly higher F1. Well, you may only rank by a single metric. That's what trivia tournaments do too. You may wish to recognize the highest scoring model that was built by undergrads, took no more than 1 second, for example, was only trained on Wikipedia, etc. Finally, if you want to make computer-human comparisons, pick the right humans. Paraphrasing a participant of the 2019 MRQA workshop, a system better than the average human at brain surgery does not imply superhuman performance in brain surgery. Likewise, beating a distracted crowd worker on question answering is not question answering's endgame. If your task is realistic, fun, and challenging, you will find experts to play against your computer. Not only will this give you more human baselines worth reporting, these opponents can also tell you how to fix your QA dataset. After all, they've been at it longer than you have. If you've made it this far, thanks for coming along on this experiment where I use a recorded reading of a paper to help me spot typos. It's been helpful for me. Hopefully you enjoyed this video too. If you liked it, please leave a comment, and maybe we'll do this in the future.